Several months ago, I came across this picture on Twitter, and impressed by how good the CG was, I started to read about where it came from. And as I learned more and more about it, I kept saying to myself, I'm going to make this video, but I kept putting it off. Then, David Willis announced he was making a video about it, which is great because he's good at those. But also now is the best possible time to make this video. So here we are. Direct has quite a lot of depth to it, as it changed over the years as the political environment and the technological environment also changed around it. So I want to take you through the whole process from right at the beginning and how Direct and the Jupiter rocket also changed along with it. So Direct actually starts in 2003 with the Columbia disaster, because it's at that point that the shuttle ended, essentially. Obviously, it flew several more times, but these flights were only to finish the assembly of the space station and one Hubble surfacing flight. In fact, for all of these missions, there was always a second shuttle ready. There are sometimes these sort of double shuttle pictures, and these are all from these, and these are called the launch on need shuttles. So the Columbia disaster caused this kind of big political problem. So the then President George W. Bush published this vision for space exploration, and it had these 6 aims for the future of NASA, the immediate future. So the first one was to complete the ISS by 2010. The second was to retire the shuttle in 2010 after completing the ISS. To then develop a new crew exploration vehicle by 2008. To explore the moon robotically from 2008, fly humans back into space by 2014, and then to land humans on the moon again by 2020. Now, obviously, in hindsight, none of these happened. The ISS finished last week with Shuttle. The shuttle retired in 2011. Orion has still yet to fly, that we'll hopefully do soon. No one's been back to the moon except for the Chinese. Humans didn't fly until 2019 on a Crew Dragon, and humans probably won't make it back to the moon until 22, 23. But we have to remember this is 2004, 2005. This is still quite a long way in the future for them. But these principles are important to the rest of the Direct story because these are the aims, these are what people are trying to do. However, the VSE is just a political statement. There's no how, it's just the what. The how is left up to NASA. And so NASA started crunching the numbers, and in late 2005, NASA published this Exploration Systems Architecture Study, which is a 758-page report that I read so that you don't have to. This is what then becomes the Constellation program. Fast forward a little under a year to mid-2006, and Constellation is now in full swing. However, some people are starting to wonder if maybe they're not going to work, and we're going to look at why that is. So from the ESAS report, the original proposal that then becomes Constellation is a 2-launch vehicle system. It is the crew-rated LV 13.1 and the heavy lifter LV 27.3. These then get renamed the Ares 1 and the Ares 5 respectively. Ares 1 is a 4-segment SRB with a modified air-startable space shuttle main engine as a second stage, and that would put the Orion spacecraft in low Earth orbit. The Ares 5 has a sort of a stretched tank with 5 space shuttle main engines and 2 5-segment SRBs, with a J2S Plus engine, which was to be developed to send the Altair lander to Leo and then to the moon after rendezvousing with Orion. However, things start to go wrong. The Ares 1 loses the space shuttle main engine upper stage, replacing it with the J2X engine. So the J2X is touted to be derived from the Apollo era J2 engine, using the J2S as a stepping stone, which itself was developed for post-Saturn, post-Apollo missions, that really shares only a name in common because it's been completely redesigned with new materials, new manufacturing techniques, and all that. And the Ares 5 replaces the 5 Space Shuttle engines on the core stage with 6 RS-68 engines, which were to be upgraded to a 106% rated power level. So what? They swapped out some engines. What's the big deal? Well, the Space Shuttle engine is just a really damn good engine. The lower overall performance of the RS-68 means that the Ares 5 could now no longer reach even orbit. So to make up the difference, the first stage tank increased in diameter. I mean, it was already stretched for the 5-segment SLBs because the mounting points at the top of the SLBs are in the interstage. But they now increased the diameter from the 8.4 meters in the shuttle external tank to 10 meters. The second stage J2S Plus engine was then replaced with the J2X, a more powerful engine overall to sort of close the gap to orbit. However, like I was saying, the RS-25 is a really efficient engine. The Ares 1 in this configuration can actually no longer put Orion into orbit at all. So they switched to a 5-segment side rocket booster with also a new fuel mix for high thrust. The problem is that now you require a whole new control system, and also the boost is now traveling too fast to maybe recover. So now the Ares 1 and the Ares 5 which were once built primarily out of shuttle hardware with the SRBs and Space Shuttle main engines, were now constructed almost entirely of undeveloped rocket technology. To make things worse, the existing sort of manufacturing, servicing, and launch infrastructure from the shuttle program can no longer accommodate the Ares 5 because the tank has increased in size. The mobile launch platform and the launch umbilical towers would need to be completely redesigned due to the extra weight and the extra size. The VAB platforms will need to be rebuilt to fit around the tank size. The manufacturing plant needs all the tooling replaced. The Pegasus barge, which transports the shuttle external tank to the VAB, would have to be replaced. So the switch away from the Space Shuttle main engines essentially reset the entire program to a clean sheet design, which completely undoes the entire aim of using shuttle hardware in the first place. Another side effect of having to redesign and then test and then fly and then crew rate all this new hardware is that it also pushes the Orion's first flight from 2011 to 2015. So it slipped a few years. What's the big deal? Well, there's two big problems here. The first one, at this time, the International Space Station is slated to be deactivated in 2014. So the idea of having Orion ferry crew to the space station is completely moot at this point. And the second one is politics, of course it is. Because this pushes the Ares 1 flight and the Ares 5 development so far ahead that a change of political power is essentially guaranteed. Which now, the problem with that is you replace your politicians who like Constellation with people who sort of inherited it and its costs and its problems. All their interest by then will have narrowed to just getting Orion and Ares 1 operational so that we can stop paying the Russians in dollars and embarrassment for rides to the ISS. Ares 5 will hold no interest for them, nor will the Moon. The Moon and Mars will be lost to us, again. Ares 5 will never be built. We are going to end up with the Congress funding one and only one launch vehicle. That launch vehicle needs to be capable of going to the Moon. Otherwise, we will be stuck in Leo for another 30 years. Only one vehicle for 30 years. This quote is from 2007, by the way, from Chuck Longton, who was one of the Direct team. This is the environment that Direct comes out of. So, where does it come from? You see, the inline shuttle-derived launch vehicle is not at all a new design. In the ESAS report itself, there's a shuttle external tank modified to put payload on with 3 Space Shuttle main engines mounted underneath and a payload shroud above called the LV-25. This was ignored by ESAS, however, due to not having enough lunar performance for the crew exploration vehicle, requiring a second launcher, which they then called the LV-24, to launch separately. Now being this kind of two-rocket system, ESAS dismissed this idea. So in mid-2006, on the NASA Spaceflight forums, a guy called Ross Tierney suggested switching out the 3 RS-25 for 2 RS-68s. Now, if you've ever been online, especially in the space sort of community, the kind of phrases, why don't they just, or what if they, are massively overused. And usually don't really mean anything. However, shortly after making this post, Ross Tierney was inundated by private messages and emails saying things like, you're on the right path, and this is the direction NASA should be going. And a lot of these emails were sent by actual engineers and space professionals who worked at NASA and its contractors. Because at the time in NASA, there's this sort of intense fear in the industry that you can't speak out against the people who, pay your wages. And in an industry like the aerospace, I don't need to explain to you why that's a terrible idea. But I didn't suffer from that problem. My paycheck didn't come from NASA. So I asked if I could be used as a conduit to say the things they couldn't risk saying themselves. And that was where the snowball began to roll. So Ross puts together a small team of people and a short paper to sort of formulate a more concrete plan with 5 main driving imperatives. The first one, minimize the gap in American manned capability between the Shuttle and Orion. Number 2, retain at a minimum the space shuttle lift capacity to LEO. 3, do not duplicate the lift capability that is already available in US-based launch services. 4, preserve and reuse the existing STS launch infrastructure at the Kennedy Space Center and elsewhere in the US. Number 5, preserve and reuse the existing manufacturing infrastructure used by STS. So, we're going to start with point 2. The shuttle's low Earth orbit capability was 27 metric tons. As for point 3, Delta IV Heavy can lift 28 metric tons, Atlas V 551 can lift 18 metric tons, and Ares 1 is expected to launch 25.4. We'll talk about the evolved expendable launch vehicles later. The first point, the gap. This is actually a really important and a really big deal, and will come up constantly over the whole story. You see, NASA is a government agency, and it employs thousands of highly skilled workers across the entire United States. It's through trying to win the votes of these people that the members of Congress mandate NASA's funding and its guidelines. In this image, you can see the projected workforce numbers between the last shuttle and the first Orion flights. And the thing about highly skilled workers like these is they're not going to sit around for a couple of years while you do your admin and finalize your rocket design. They go and get another job, and then they don't come back, and you lose their expertise in the program forever. And in fact, at this time, this had already happened.
There was an enormous brain drain following Apollo 17. There were literally thousands and thousands of people made redundant while that mission was actually occurring. I'm here in the Cape Canaveral area, and it's embedded in the mental psyche of everybody here. The house prices just disappeared overnight. People literally
ghost town.
Literally just left their keys in the doors and walked away.
So point 4 is how we avoid this gap. We must retain as many of those workers as possible by simply retaining as much of the rocket as possible. And as for point 5, ground equipment is just expensive. So, after a couple of months, in the 25th of October 2006, Direct version 1 goes live on NASA Spaceflight forums. To mixed reactions. It eventually garnered enough attention that the ESAS lead, Dr. Doug Stanley, offered to look through the proposal in his own time, which is that's like what you want, right? Well, he promptly tore Direct version 1 up one side and down the other. That almost outright killed Direct then and there, after just 3 months. But instead, the team works to tackle all these points of criticism that have been brought up, and then on the 10th of May 2007, Direct version 2 goes live. This is an important point because Direct version 2, one of the people they added to the team was Philip Metchan. Who is he? Well, he made this image that started this whole thing. In fact, he made several images, and it's not actually that surprising he made such a good image because he worked at Pixar. There's a non-zero chance these were made on Pixar machines. Anyway, so you notice that I've skipped over version 1, and I still haven't told you what directive it is. Well, that was because this is the time where Direct starts to pick up some kind of public footing, which is great because various internet archive systems actually start picking up their documents. So, what's in them, and what is it? So, we're starting with the shuttle stack, and this is ironically common to all the shuttle-derived vehicles. The first step is to reboot the shuttle. We'll also get rid of the SRBs, but we'll put them back shortly. So here we have the external tank. Removing the Sophie on the outside, we can see the hydrogen tank is in red and the LOX tank is in green. So in order to mount payloads and or second stages on this, we're going to have to do something about this OGIV LOX tank section on the top. Direct suggests using these tank sections that we already have for the LOX tank and simply repurposing them as the top. We then put a small interstage on the top to cover the tank dome. The hydrogen tank actually remains essentially unchanged here, but we do need a new thrust structure installed on the bottom with these 3 mounting points for the RS-68 engines. The centre mounting point isn't actually necessary for all the mission profiles, but we'll get to that shortly. This makes up the Jupiter Common Core Booster, and we then put the 2 STS standard 4-segment SRBs back on the exact same mounting points, and we complete the first stage of the Jupiter launch system. The naming system was Jupiter, followed by 3 numbers. The first indicates the number of stages up until orbital insertion. The second is the number of first stage engines, and the third is the number of second stage engines. Wait. RS-68 engines? Well, didn't they completely break the Ares 5? Well, yes, but no. This gets complicated, but it's rocket science, so you should expect that. The Space Shuttle main engine was a primary choice for all the reasons of reusing shuttle tech, as I've already talked about. However, the Jupiter is expected to be launching about 6 times a year. Now, this may sound a lot, but currently, commercial orbital transportation services and commercial crew flights today are about 4 or 5, sometimes 6. This is roughly the same. The Direct team did not think that a Space Shuttle main engine could be manufactured that fast, because it's not designed for it. It's a reusable engine. You're only supposed to make them once, and then fly them 30 times. So, while searching for an alternative, they settled on the regeneratively cooled version of the RS-68, which I will call the RS-68R from now on. The problem is the RS-68R doesn't exist, but the RS-68 was actually designed with this path to upgrade in the first place. I still haven't answered, why doesn't this break Jupiter in the same way it breaks the Ares 5? Well, the difference is that the J2X is on the critical path, because it's on the Ares 1, the crew launch vehicle that's supposed to come first. You see, Jupiter can get crew into orbit with completely unmodified RS-68s. Ares 1 requires the full development, testing, production, and certification of the J2X before it can ever fly in Orion at all. And the RS-68 could be put into mass production in the way that the Space Shuttle main engine cannot, because it's got 80% less parts, it's cheaper, etc. And as part of the VSE was this idea of the Moon, Mars, and beyond, and this aspect also works its way into Direct. A lot of detail is put into lunar operations in this document. Phasing orbits, lunar base landing approach directions are all talked about. Halo orbits for communication, utilization of Earth-Moon Lagrange points for landers, and all this is considered. In fact, Jupiter's versatility makes it kind of hard to explain exactly what their plans were, because they made so many options. As I understand it, the best option in version 2 is this one. There's actually another version which uses a fuel depot in low Earth orbit, another one with a reusable LSAM in Earth-Moon Lagrange points, and a direct descent version. The direct descent version could be modified for asteroid missions, including a gravity tether. This version could then be further modified into a Mars lander version. The direct's versatility and adaptability and evolvability is really quite something that I've never seen in any other program. So now I'm going to jump ahead to Direct version 3. We've now gone from 2006, 2007 to 2009. There have been several really important changes in this time. Firstly, the 2008 financial crash. This is really important because suddenly everybody's thinking about the cost. People are questioning whether NASA should get as much money as it does because thousands of people are struggling to survive at this time. See, Constellation is this kind of huge cash cow that people just keep swinging at. And I'm pretty sure that this is the origin of the mindset that we still have today. Direct begins to really focus on not only their much cheaper system, but also on public outreach. In fact, I explained much of the engineering using the version 2 design because there isn't that much equivalent for version 3, just sort of a lot of presentation-esque documents. See, the 45th Space Wing runs all the space operations at Cape Canaveral, and they run a study on the Ares 1 that concluded that an abort at certain parts of the ascent would lead to a 100% chance of loss of crew, because the Orion spacecraft, after aborting from the rocket, would have its parachutes incinerated by burning SRB fragments. Reports differ as to whether that would happen or not or whatever, but the problem is that any chance of 100% chance of lost crew is a no-go. It's not acceptable. Now, Jupiter also uses the SRBs. They still also have to answer this question, and many simulations are run, but Jupiter has one really big advantage that the Ares 1 does: a lot of spare mass. You see, the biggest, the quick and dirty solution to fixing this problem is a sustainer motor on the launch escape system. Essentially, you have the big high thrust to hoik it out of the way, and then you have a slow burning thrust to sort of carry it further and further away over time. The problem is this adds mass. Ares 1 does not have the mass budget. It's already failing to put the Orion directly into orbit. It has to use the service module to make it. Jupiter has so much spare mass, it could have launched another Orion. Or two more, actually. So why so much up mass on the Jupiter? Well, the really big change here for version 3 is the engines are back to being Space Shuttle main engines again, with 3 or 4, depending on the mission profile. So what happened with the RS-68s? Well, the RS-68 was not, and still is not, crew rated, and was not, and is not, upgraded to the RS-68R, because, well, NASA decided they weren't going to do that. And now Direct is running out of time. We've lost 3 years, and it takes time to develop new engines, and now Shuttle is only a year away from retirement. It's 2009, it's retiring in 2010. However, this has an interesting bonus effect, because I've already spoken about how the Space Shuttle main engine is a really high efficiency engine, and using them instead bumps the payload from 40 to 60 metric tons all the way up to 100. This means that for like the later lunar missions, you can actually use a smaller second stage. And because of this mass reduction, considering that most of a rocket's mass is fuel, you can now use the more efficient RL-10 family of engines. In fact, Direct version 3 offers 4 different second stage engine layouts. 1 J2X, 4 RL-60s, 7 RL-10A-4-2s, these are currently flying the Atlas V, or 6 RL-10B-2s, as flies on the Delta cryogenic second stage. The J2X we've already spoken about. Direct actually includes this as an option to retain the money already spent during the Constellation program on developing it. These two RL-10 versions differ slightly in that the B2 has a extendable nozzle and has a slightly higher efficiency. The RL-60 is somewhat similar to the RL-10, about 3 times the thrust and a lot more engine restarts. However, in hindsight, this engine never went anywhere. And in fact, there's an interesting development to the depot design. Since fuel can be divided up arbitrarily small, Direct proposes getting international partners to fly fuel up to this depot, which they can then exchange for seats around the moon. This then preserves international cooperation, but also keeps sort of the technology under sort of NASA's belt. So, like I said, it's 2009, and Barack Obama is now the president, and they decide to conduct a review of the state of U.S. human spaceflight, due to Constellation sort of spiraling out of control with its costs. And it was headed by Norman Augustine, and it's then often referred to as the Augustine Commission. And after a period of analysis, they find the Constellation program to be so far behind that it would never actually reach any of its goals.
You look out at the right part of the chart and you discover that we are on a path right now for a system that requires, on the close order of double the current budget just to operate.
That's the steady state numbers you can see. You're kind of approaching steady state there out in
Right.
2028 or so,
if
that's the operation.
If Santa Claus brought us this system tomorrow, fully developed, and the budget didn't change, our next action would have to be to cancel it.
Yeah.
The other part of the problem is, even when you look at what we're calling the less constrained scenario, what's Ares 1 for? Well, it's ultimately for bringing Orion to the ISS. But we actually haven't got a scenario in which you can get that capability before ISS is about ready to splash. If you retire ISS in 2015, you can get Ares Orion 1 in around 2016. That's not so helpful.
So as you can see, the Constellation program is dying. And on October the 11th of 2010, President Obama signs the NASA Authorization Act of 2010, which, among other things, kills Constellation. In fact, only Orion survives. It then mandates the work on this new space launch system. It expands the commercial orbital transportation services and also starts up the Commercial Crew Development Program. You see, with commercial orbital transportation services taking care of the low Earth orbit and International Space Station resupply, this changes the whole game because NASA now no longer has to think about that. They can think instead primarily on a lunar-rated rocket. You see, the light version of the Jupiter rocket, the Jupiter 130, was designed to fly only to low Earth orbit. And now, over this whole time, the contract for the 5-segment SLBs has slowly been increasing in price. Jupiter no longer really made sense because it was too underpowered for going to the moon, which was the original reason ESAS didn't go with it. And over the next year or so, the design for the SLS was actually hammered out. And what they originally settled on was a Jupiter 241 with a stretched core, so to fit the 5-segment SRBs. With the Space Launch System being very much more shuttle-derived than Constellation ever was, the Direct team declares their effort a success, and they disband in October. So there are a couple of other things that I couldn't really fit in the sort of narrative of this that I think are also really interesting. So the first thing is, Direct always made sure to make use of all of the contracts that were already signed for Constellation. However, the only one they could never really find a use for was these 5-segment solar rocket boosters, because the Jupiter just didn't need them. It's only at the end of this sort of program that they ever actually start seriously considering 5-segment versions of the Jupiter. However, the mounting points of the SRBs are at the top of the booster and in the interstage of the tank. And for the Space Launch System, they would stretch both the boosters and the tank. But for Jupiter, they didn't want to change the tank at all, because the whole point was to reuse it as much as possible. So instead, they would have the mounting point at the top of the 4 segment and then just put the fifth segment on top. And while we're on the topic of space shuttle SRBs, there's this kind of oscillation in the thrust in a space shuttle SRB at around 13 hertz. You see, the external mounting points are designed in a way that sort of bends to absorb this. But the problem with the Ares 1 is you can't do this because it goes straight up through the tank of the second stage. So the preliminary tests on this, on the Ares 1, suggested that this 13 hertz oscillation happens at about 4 Gs. That's not good. That's really bad, actually. That will quite literally shake parts of you apart. This remained, and still remains, an unsolved problem. There are arguments as to whether this is actually as bad as it sounds, or it actually is as bad as it sounds. But either way, I guess, hopefully we'll never have to know. And I spoke earlier about evolved expendable launch vehicles. And it's kind of tricky to involve it in the story because they are something completely different. In case you're wondering exactly what I mean, I'm talking about an Atlas V Heavy and a Delta IV Heavy. Now, the reason these are never really a serious contender is because they're not, like I was saying, NASA is a public organization and they hire all these thousands of engineers. But the evolved expendable launch vehicles are run by private organizations. So they just don't have this funding base in Congress. Congress don't want to use them because they then have to fire the people that vote for them, and they don't want that. So as a result, these rockets are never really considered. They're more like the gotcha argument that never really actually makes any sense. And hence, we've never got an Atlas V Heavy because it just doesn't make sense. There's no market for it. However, the Delta IV's upper stage ends up as the basis for the interim cryogenic propulsion stage on the Space Launch System, although it's only supposed to fly 3 times. A similar thing was actually suggested on Direct. You could just put an Orion on a DCSS on a Jupiter and send it around the moon Apollo 8 style. I want to talk about something in David's video real quick. It's about the Jupiter 120 specifically, because it is technically part of the offer for Direct version 3, but it wasn't a serious consideration because it had no edging out capability and its abort modes were a little dicey, so they went with the 130 or 13X series because it was just a better all-round, technically more expensive, but when you're dealing with the development cost for the Ares 1, it really made quite a large saving. So yeah, that's the history of Directs and how it changed over the last couple of years. I've never made a video like this before. I may not make one again. So, I guess thanks for listening to me ramble. This has been a long couple of months for me. So yeah, that should be David's Direct video. That should be his Constellation one. You should definitely watch those. They're really good. Up here is a video that I once made on the 0X, which is my favourite ship ever. I like it.